All right. Well, we begin.
Only the strong survive.
Yeah, only the strong survive. Yeah. All right. Well, so yeah, we have our exam a week from today. I sent the review out for it yesterday. I'll put the review here on our screen so you can see. Where's my mouse? There it is. Okay. The review, let's take a quick glance at it here. You're going to have some transformations on there. You're also going to have some stuff with quadratic functions. We spent some time on quadratic functions. Sketching quadratic function number 3. So remember there's a bunch of steps for that. And then we get on to number 4, polynomial functions. Want to sketch polynomial functions. And then we get to number 7, number 8. That's rational functions. And then inequalities, this is not going to be on the test because we're going to cover that on Tuesday, so I won't test you on it 2 days later. So you won't have anything on inequalities. But then I also said to look at the exam 1 review, right? I believe I did say that in the email, right? Yeah, but it was something else. Hold on. On exam 1 review, there was a problem that I told you to not worry about on that exam, and it was this one right here, number 16. It was a piecewise function. So if you're trying to think like topic-wise, what's going to be on the exam a week from today, you're going to have piecewise functions, you're going to have transformations, you're going to have quadratic functions, you're going to have polynomial functions, and rational functions. So it's a lot, right? So because of the time, we only have 100 minutes to take the test, right? So I can't possibly give you like 4 rational functions to graph. I can only probably give you 1. I can only give you probably 1 polynomial, 1 quadratic, right? So there's probably going to be not many problems on the test, maybe 6 problems, something like that, 7. So, I mean, I realize that makes it like high stakes, right? You miss 1, it's like, oh my gosh, but you know, that's why we study. That's why we prepare, right? So, okay, the exam's next Thursday. Review's been emailed. Today I'm going to do more rational functions. I don't plan on talking about, am I recording? I forgot if I hit record, yeah. I don't really plan on talking much about the review. I want you to have some time over the weekend to go through that. And then on Tuesday I'm going to start inequalities. We've done inequalities already, but now we're going to do rational inequalities instead of quadratic inequalities. And then hopefully we can spend half of next class reviewing, but that means you're going to have questions because you know, I don't want to just stand here and be like, do you have questions? And no one has questions, and we just wasted time, you know? So, yeah, any questions on this? No? All right, let's get down to business then. My goal today, and it's pretty ambitious, is to see if I can sketch 4 rational functions. We're going to try and do 4 problems today. And I gave you the set of steps last class on how to sketch rational functions, and that's what I'm going to be following today. The first function that I'd like for us to do, and if you tried the homework and had any problems, okay, don't worry about it. Let's do these, and then I think the homework problems are going to be much easier because you'll have 4 more examples to go off. So here we go. We want to sketch this. F of x equals, let's see, x cubed plus 9x squared plus 6x minus 56 all over x to the 4th plus 2x cubed. Okay. So that is a rational function because it is a polynomial divided by a polynomial, and it looks terrible, doesn't it? This looks absolutely horrible. But we're just going to chip away at it 1 step at a time, and then at the end we put all the information together. All right. What is our first step? According to your steps that you wrote down because you're good note takers. You're thinking of polynomials. Factor, good. Factor. We want to factor the numerator and denominator. right? So we want to factor the numerator and denominator separately, right? Okay, let's look at the numerator. Shit, we got to factor the numerator, right?
Yep.
That sucks. Okay, we got to factor the numerator. So for my numerator, when I go to factor this, the first thing you always look for is what? Greatest common factor. So do we have a GCF? Is there something you pull out of everything? No, right? All right, so how do we factor this? Synthetic division. Unless you know how to do 4 terms, but even if you know how to do 4 terms, well, will it work? It might work, might not. No, I don't think it's going to work. Let's go to synthetic. Synthetic has been good to us, hasn't it? Now, I'm going to run pretty quickly through the synthetic because I'm trying to get through 4 problems today, all right? So I'm going to set up my list of numbers, right? And I know that I can have 1 in 56, right? I'm only looking at this number because this is a 1 up front, right? So I don't really care about making that other list. Let's see, 2 and 28, and so on and so forth, right? I'm going to make my list. Then I'm going to start with 1, then -1, then 2, then -2, right? Okay, can I just get to what works? Y'all sure? Y'all need to let me know because this is, I don't want to waste time, but I also don't want to gloss over something if you have a question. We're good? Okay, so get to synthetic. Inside the box, I've got 1, I've got 9, I've got 6, I've got -56. And the first number that should work, I believe, is 2. It might be -2. Let me try 2. 1 comes down. 2 times 1 is 2. Add down, I get 11. 2 times 11, 22. Yeah, I think this is it. 6 and 22 is 28. I'm adding, right? 2 times 28 is 56. And then when I put those together, I get 0. So yes, I'm happy about this, right? Okay, so now what that tells me is that this original polynomial now factors to be what here? X minus 2, right? It's the opposite of what we see here. And then these are the, oh, you need a chair? You got it? Okay, don't hurt yourself. All right, so these are the coefficients of what remains. So I should have a 28 in front of that 11x, in front of that x squared. So x squared, okay, plus 11x plus 28. Now, we could continue with synthetic division, couldn't we? But this is a quadratic, and I think we played this game enough in the past that maybe we can just do this. What are the numbers? Seven and 4. Okay, so now we have x minus 2. This will become x plus 7, x plus 4. All right? Again, that might take you a little longer. Or if you did synthetic division, can anyone tell me if you were to have continued with synthetic division, by me giving you this answer, can you tell me what would be the next number that would have worked?
-7.
-7 would have worked, but if you were following the order, it would have been -4 would have worked first. Okay? So just so you know, if you didn't do that, then you would just continue synthetic. -4 would be the next number that works. All right? I'll continue. Numerator is factored. Okay, now denominator. Let's do denominator. I'll just do it right here. So for the denominator, I take x to the 4th plus 2x cubed. Try and factor that. First step is GCF. I do have a GCF, don't I? X cubed. So I can pull out x cubed, and that leaves me with x plus 2. And that is completely factored. There's not much more I can do with this, right? So I have finished step 1. Step 1 is I can rewrite the function in its completely factored form, which is x minus 2 times x plus 7 times x plus 4, and that's all over x cubed times x plus 2, right? Okay, now, that's step 1. What does step 1 say? Factor and what? Is that it? So what's step 2? Holes, okay? Holes. Do we have any holes? Well, what am I looking for holes?
If any factors cancel out.
Yeah, if I have any common factors, right? Or is there anything that cancels? And by looking at that, do y'all see there's nothing that cancels? Right? So no holes. That's good. I will do an example today where we have a hole, all right? If we get to it, it's the fourth example. All right. What's the next step? Third step. X-intercepts. Okay, how do we find the x-intercepts? Which ones? Numerator. So you set the numerator, right? Set the numerator equal to 0. So that's x minus 2, x plus 7, x plus 4, set it equal to 0. And the whole reason we factored it is so we could find holes, but also so we can make this step easy, right? We should get 3 solutions when we set each of these equal to 0.
Positive 2, negative 7.
Hold on. Yes, sir. I got you. Those are the answers, yes.
Sorry.
It's all right. Good. We have 3 x-intercepts. These are dots on the x-axis, right? These are dots on the x-axis. Okay. Fourth step, we want the vertical asymptotes, right? And to do that, we set the denominator equal to 0. Well, that's already factored also, right? Denominator equal to 0. And just be a little careful here, because when you're setting x cubed to 0, you're really saying, like what number cubed is 0? And the only number is 0 itself, right? So 0 and the other one gives you negative 2. 0 and negative 2.
Can we just do that?
What do you mean?
Since the numerator, the leading coefficient in the numerator, the power is less than the denominator.
What about that?
That's the rule, eh?
You're talking about horizontals. I think you're thinking about horizontal asymptotes.
Oh, my bad.
Yeah. So for vertical asymptotes, all you do is set the denominator equal to 0. But now let's do that step. That's our next step. Any questions?
Oh.
Okay, so now pardon?
Just one.
Yes.
What happens when I have something that does cancel? What happens when I have something that does cancel?
You mean the beginning with a hole?
Yes.
I'm going to show you an example of that.
Okay.
Just not yet. We'll get to one. Okay, so now we want the horizontal asymptotes. Now, this is where we compare the degree of the numerator and denominator together, right? This is where we go and we say, okay, look at what's the degree of the numerator, what's the degree of the denominator, right? That somehow dictates what's going to happen with the horizontal asymptote. And I only gave you one example last class. And the example I gave you was when this number is smaller than this number. And that's the same number, that's the same example I'm giving you right now. The example that I do next, these numbers are going to be the same, and the example I do after that, this number is going to be bigger than that one. Okay, so that way you see all 3 cases of what could happen, all right? So for horizontal asymptote, I look at the degree of the numerator, I'm going to call it n, and I compare it to the degree of the denominator. All right, and in this case, the degree of the numerator is smaller than the degree of the denominator, right? When this happens, okay, so if this happens, because that's a what? That's a 3 for us, and then this right here is a 4. When this happens, y equals 0, which is the same as the x-axis, is your horizontal asymptote. Anytime the degree of the numerator is smaller than the denominator, then your x-axis is your horizontal asymptote. All right, we are done with step 5. Now, there was a step 6 that was called test points, but to get test points, you need to have a sketch. So we need to draw a little sketch. Before you take a picture, hold on, before you take a picture, I want to add something to this. All right, so in a recap here, the x-intercepts visually on our graph, these are points, right? Points on the x-axis, right? These vertical asymptotes are these vertical dotted lines that act like barriers, right? So these are vertical dotted, like barriers kind of? We can't cross these, right? We cannot go through those. But they're technically not part of the graph. They're just there to help us draw the graph. The horizontal asymptote is well, it's a horizontal line, right? But this is what gives us the end behavior. End behavior only, okay? Only, all right? This is the big thing. You only want to draw this dotted line at the edges, okay? And remember, it acts like a magnet, right? And it like pulls your graph towards it, right? But only draw it at the ends. Okay, now you can take a picture. I'll get out of the way. No? All right? Okay. All right, so let's try and draw this picture of what this function looks like. And then as we draw it, we're going to see we're going to need some test points. So I'll put it over here. All right, so here's my XY axis. I'll start, my graph will be in blue, all right? So I'm going to start with my x-intercepts. I've got one way back here at -7. I've got one at -4. And notice I'm not like counting like 1, 2, 3, 4. I'm just putting them in order from left to right, and then 2. There we go. Those are x-intercepts. Now, my vertical dotted lines, I'm going to put in red because they're actually not part of my graph. My vertical dotted lines are at 0 and -2. Okay, -2's right here, right? And I need a dotted line here. In hindsight, I wish I would have made this a little wider, but I could always draw it over, right, if I wanted to. I have another one at where? 0. Okay, this is a little tricky, especially if you don't have colors. It's a little tricky to draw a dotted line on top of a solid line. So one thing you can do is do your dashes kind of at an angle, and that way you can see it. Just make sure you understand that that's your vertical. 2 verticals. And then in green, I'll do my horizontal. My horizontal is the x-axis, right? But I'm only drawing it out at the edges. I am not going to draw my horizontal through the entire middle. Do you see that would cause some issues if you drew it through here? You'd be like going through your x-intercepts. You'd be like, what the hell's going on here? So only draw it at the edges. All right, now, I need to now determine exactly what this graph is doing. So I need some additional points to help me. And so these are where we get our test points from. So I don't have any more colors. So for test points, do you remember me telling you how many you're going to have? 4? What determines how many you have? 1 higher than what degree? Not necessarily. It actually has nothing to do with the degree. It has to do with how many x-intercepts you have and how many verticals you have. So how many how many x-intercepts do we have? 3. How many verticals? 2. That's a total of 5, right? We need 1 more than that. So we need 6 test points. Yes, it's going to suck, okay? It's going to suck. We have to have 6 test points. Now, the key is that you can't just pick randomly any 6 points you want. You have to make sure that you have a test point in between, like in all the regions where you don't know what's happening. Like to the left of this point, I don't know what's happening, other than it's flattening out, but I don't know if it's coming in from the top or the bottom. So I'll need a test point over here. I don't know, what do you say, -8? I'm going to circle it. I told y'all last time, also put an X there. Don't put a dot. If you put a dot, you might think it's an x-intercept, right? Where else do I need one? Between -7 and -4, so I heard -5. You can do -6. Where else? -3. See, I kind of wish I would have spread this out a little bit more to give me room. I need something between here and here because I don't know if this graph goes up or down here. So -3. I need another one here. Shit, -1. See, between my 2 verticals, I don't know what's happening. And then right here, I need 1. And finally something over here, like 3. Yeah, I really do wish I would have spread this out a little bit more. You could do 15, yeah. You could do any number you want, as long as it's to the right of 2. All right, so this is step 6 now. I'm going to take those 6 test points, and I'm going to evaluate my function at those 6 test points. Now, nobody wants to plug those numbers into this, right? If you did, you would actually get the exact answer. But what we're interested in in this class is just figuring out whether or not our graph is above or below the x-axis at these test points. So I just want to determine if it's positive or negative. And so this is where I told you all last time, it's better to plug your test points into this because it's easier, right? You'll see as we do it right here. So this is step 6. How are we doing on time? 20 minutes? I've got 25 minutes per problem here. So let's see. Step 6, test points. All right, so the first test point I'm going to plug in is -8. Okay, so what this means is that I replace all my x's in this factored form with -8 and just figure out if I get a positive or negative. So if I plug -8 right here, -8 take away 2 is -10, yes? So I like to put a little negative sign, I like to put a little circle around it. I have a negative number there, times -8 plus 7, -1, negative number, times -8 plus 4, negative, and then over, okay, -8 cubed, -8 times -8 times -8, still negative, right? Times, and then -8 plus 2 is negative. Everything was negative, right? So let's see what happens at the end of this. If I multiply, let's see, the bottom is positive, isn't it? Because 2 negatives multiply to be positive. Then these 2 negatives become positive, but then I multiply that times a negative, so my top is negative. And a negative divided by a positive is negative. Okay, I've got to do that for 5 more points, right? So to save us time, I'm just going to give you the answers. Is that all right? Or do y'all want me to see me do another one? No, don't? No? Okay, so on a test, yes, it's going to suck. You have to do this, but -5, let's see, -3 goes next, then -1, and then 1, and then 3. Okay, in this particular problem, they should alternate. They should go back and forth. So it should go plus, then minus, then plus, then minus, then plus. It doesn't always do that, all right? It does here, though.
Wait, so do you just like do that in your head, or do you have like a way of doing that?
How am I doing it?
Yeah.
Just because I know some other things that if we go down that road, we just spend too much time. We spend more time learning that than just plugging in numbers, you know? And it's not really that vital. Now in the last class, or in the last topic, polynomial functions, right? It was multiplicity that told us bounce and cross, so we didn't need test points, right? With polynomials, we could have done test points, but we didn't need them because the multiplicity helped us draw it. Does that make sense to you? Yeah. Here it's just easiest just to pick some points. All right, so now let me get my blue pen back out because these points that I put here are part of my graph. So at -8, I am where? Down, right? So I'm gonna come down, boom. Anywhere you want, okay? It can be here, it can be way down here, does not matter. At -5, you are above, so anywhere I want, I'll put it here. At -3, I'm down, so I'll put it here. At -1, I'm up, so I'll put it here. At 1, I'm down, so here. And then at 3, I'm up, I'll put it here. That's a lot of points, yes? At this point, you just have to kind of like put it all together, think through what has to happen, right? Remember, you have to draw something that can be drawn without, well, no, sorry, strike that. It needs to pass the vertical line test, right? So it has to be a function. And then it has to like be, you know, the behavior is dictated by all these asymptotes, these horizontals and magnets and barriers and x-intercepts, right? You got to think it all through. So I told you last time, just go to your first point and imagine what would happen if I started to draw the graph this way. Well, I've got a magnet, right? The magnet pulls me towards it. So I know I'm going to get pulled up here towards that there, okay? Now, standing at that same point, looking this way and starting to draw, I see that I have a point up here I need to get to, right? So I've got to get up to that point, and then from that point, where do I go? Up to that point, right? And then down to that point. Then you're back in kindergarten, right? Connecting dots. You're just connecting dots. There's nothing in your way, no problems. So connect, connect, connect. Okay, this one's a little bit tricky because it's so small. Like I should have given myself more space. But at this point right here, if I'm drawing that way, which way do I have to go? I have to go down, right? And I told you again last time that you're not going down because it looks like you're going down, right? You're not. The reason you're going down is because to turn up would mean you have what here? You would have an x-intercept or a 0, and you don't have an x-intercept up here, right? So it must go down, and that's what the barrier does anyway. The barrier forces you, like asymptotically, right? This way. That all right? Okay, the next point that I see here is this one. And if I draw it to the left, I've got a barrier in my way which forces me up or down. Which way? Up, because I don't have an x-intercept right here, right? So I have to go up. So to the left, it's going to go up like this. And then I draw it to the right, I have the barrier right there. So which way? Up as well. Why can't you go down? You would cross the x-axis. I'm not allowed to cross, right? So I have to go up. It looks like almost like a little parabola in there. It's not a parabola because parabolas go out and they get wider and wider. This is a parabola that's like stuck between two walls. So it's not a parabola. Looks kind of like one, but. All right, so now I pick up my pencil, I come over here, I go to this dot right here, and I draw this way. When I draw this way, there's the barrier. I can't turn up, right? So I have to go down, so it's going to go down. And then I'm back in kindergarten, connect the dots, and then here's a magnet that's going to pull me towards. There it is. I hope that all makes sense. Are there any questions? So I think it's pretty nice looking. Beautiful almost.
That's an ugly graph to play with.
Yeah, I would argue that that's beautiful.
I do have a question.
Okay, hold on. Let me type this in real quick. I'm going to do it on Desmos because I want to see how our graph looks compared to what Desmos gives us. Let me type it in and I'll take your question. Hold on.
Cool.
Okay, x to the 4th plus 2x cubed. Okay, if I just type into Desmos, that's what I get. What's your question?
If each equation is aligned, then how come there are 3 of them?
If each equation is a line?
Yeah.
What do you mean?
If each part.
Oh, factor. If each factor is a line, well, because you're multiplying them, right? When you take 3 linear things and multiply them, it's no longer linear, it's cubic. So you have a cubic function here, this is a 3rd degree polynomial, right? Divided by a 4th degree polynomial. And so what you get is this ugly thing. Now look at their picture, look at our picture, okay? Right now, it looks like we're wrong, right? But what I need to do is change the scale. If I scale out, we're gonna see that parabola thing. You see it there? Now, ours is not perfectly shaped like theirs, right? But I would argue that ours is almost better than that because from that graph, right now, if you look at that graph, could you tell me that between -7 and 4 that you're above the x-axis? No, right? Could you tell me that to the left of -7 you're below?
No, not
It's hard to see, right? Well, then you could zoom in maybe, right? But if you zoom in, right, if I zoom in like this, there we go. Now I can see it. Right, now I can see it. But now I don't see anything else on the graph, right? Like I don't see that U. So with the computer, it's impossible to see all of these characteristics at one time, where with this, we see it. Even though our graph's not perfect, like perfectly shaped the way it is in real life, I think we have more information here. You could argue, right? You could argue. Okay, good? 30 minutes, that took us. All right, let's move to the next one. So of the 2 examples that I've given you, where I've started with the problem, taking you all the way to the end, right? And the 2 problems I've given you, in both of them, the step where we found the horizontal asymptote, the magnet, right? The way we got it was the fact that the degree of the numerator was smaller than the denominator, right? Now it's time for an example where they are the same. And then we'll see how to deal with that, all right? And I made this one a little bit easier, so we're not going to need synthetic division, just to make it go a little faster. So we have 2x squared on top. Hold on, it's still real wet. So 2x squared minus 2x minus 40. So just a little quadratic up there. And then on the bottom, x squared minus 4. All right, first step, factor. So when I factor, let's factor the top. 2x squared minus 2x minus 40. When I factor that, GCF is always the first step, right? Do you have a GCF? 2? You can pull a 2 out, right? Let's pull a 2 out. That might help us factor a little bit easier. X squared minus x minus 20. Well, you could do your little thing here, or you could do synthetic, right? And make a list. But I'm just going to go right to what it is. Is that all right with you?
That's fine.
Okay, it is, let's see, we have a 2 here. We have x should be minus 5x plus 4. Those should be the factors. So there's my numerator factored. Is that all right? Now my denominator. Well, I hope you recognize that. That is a difference of squares, right? That is a difference of squares. X plus 2, x plus 2 times x minus 2. All right, so we are completely factored. So let me rewrite this. I'm going to just put it up here. The original function is a 2 sitting in front of x minus 5, and then times x plus 4. And then all of that is over x plus 2 times x minus 2. Okay. Step 2, holes? No holes. We don't have holes because none of these factors cancel, right? All right, step 3. X-intercepts, right? That's next. You set the top equal to 0. All right, I'm going to write something down here, and you'll tell me what you think. Well, can't get used to that. Okay. Right or wrong? Wrong. What's wrong? 2. This is a common mistake I see students make, right? Remember, what you're doing, setting it equal to 0, sorry. You're setting this equal to 0, right? So you're setting that equal to 0, that equal to 0, that equal to 0. Students will say, okay, setting that equal to 0, the answer is 2. No, because what you're doing is you're setting a number equal to 0, and that's never true. 2 is never 0. So don't accidentally put that. Imagine how much that's going to screw things up if you did that, right? If you get one thing wrong, your picture's completely off, right? So take your time, be patient, right, with yourself. 5 and negative 4, that's it, right? Let's see, next step, 4. Vertical